All right, so we'll take a look at solving some of these quadratics a little different ways. So this is by factoring. So real quick, go back and remember, how did we factor these things down? This is where we used the box method before. Remember, so a lot of times we did you put the a term, you got x squared, you had the c term 16, we did ac, so we need factors. A was 1, right? There's a 1 right there in front of the x squared, so we need factors of 16 that add up to 8. That would be 4 and 4, so you have 4x, and this is where, remember, you pulled out the GCF. The GCF here is x, the GCF here is 4, the GCF x and 4. So the factors here would be x plus 4, x plus 4. Right here, you put the a term, x squared, and then we have a negative 24 here. So we need factors of negative 24 that add up to be 5. I believe 8 and 3 will do it. We need a positive 8 and a negative 3, so we have 8x, negative 3x. So when we start pulling these out, that'll be x. And since with this particular row, since we're starting with a negative, we're going to pull a negative number out. So the common factor there is negative 3. Here, the common factor is x. Even though it's a negative, we're not starting with a negative as we go down the row. Then we'll go down this row, and the common factor here is 8. So my factors here, x minus 3, x plus 8. All right, and here's one where we have a leading coefficient that is not 1, but same process. We have 3x squared, and we have 12 here, so we got 3 times 12 is 36. We need factors of 36 that add up to 13. I think 9 and 4 will do it. So 9x, 4x. So let's go through and pull GCF. So the GCF here is 3x in this particular row. This row, the GCF looks like it's 4. As we go down, looks like we have an x. As we go down, looks like we have a 3. So looks like my two factors here, 3x plus 4, x plus 3. And remember, the way you can check these a lot of times is just work your way backwards. So how does that work with solving these things? Well, what's going to happen? We're going to eventually start setting these quadratics out to be equal to 0. We need them to equal something. And so we're using something called the zero product property, right? If you have two numbers, a times b equals 0, what you know is one of these, a or b, must be equal to 0, right? If a is 2, b has to be 0. 2 times 0 is 0. Or if a is 0, b can be any number it wants to be. If we have 0 times any number, it's still 0. So how this is going to work for us, first we need to get a 0 in there. Well, right now, you see with number 1, there's no 0. So the trick we're going to play, we're going to add 45 to both sides. And what that really ends up, we end up with x squared minus 14x plus 45. Oh, excuse me, got excited about putting a 0 in there. Equals 0. And it's at this point we have our 0. We also have something that looks like we can factor it. So take a moment. Use your box if you'd like to. So x squared goes in the top corner, 45 in the bottom. So we need factors of 45 to add up to negative 14. That's negative 9 and negative 5. So minus 9x minus 5x. So start pulling through this. I can pull an x here. Here I'm starting with a negative 5x as I work my way from left to right in the bottom row. So I can pull out a minus 5. As I work my way down, those two just have an x. So work my way down here. Again, I'm starting with a negative 9x, so minus 9. So it looks like my two factors here, x minus 5, x minus 9. Here's the trick with this. You're just basically going to set each one of these equal to 0. So x minus 5 equals 0. X minus 9 equals 0. Which means when I solve this, add 5 to both sides in this one, x can equal 5. Or, with this one, add 9 to both sides, x equals 9. Okay. I'm just going to go down and do the odds on this page. Here we don't have a 0 yet, so let's move everything over with the x squared. So we need to move the 8x over. Since that's positive, it's going to end up being, you're going to subtract 8x to both sides, and right, you'd end up subtracting 8x. You'd have to add 15. So we'll add 15 So that moves everything to the left, which leaves 0 or nothing on the left, on the right side. We use our box method to solve this thing out. So we got x squared here, 15 here. So we need factors of 15 that add up to be negative 8, and I believe that'd be negative 5 and negative 3. So minus 5x, minus 3x. Let's go through. Here we can pull out an x. We can pull out a negative 3, x, and a negative 5. So we end up with x minus 3, x minus 5. But this time again, we're going to actually solve this thing. So x minus 3 equals 0. And you just take both of those things and set them equal to 0. Add 3 to both sides over here, so x could be equal to 3. Or add 5 to both sides here, x equals 5. What you should actually notice, these numbers that are popping up right here are actually the opposites. Right? If you look closely, the numbers inside the box here are the ones that are the exact opposites of what happened there. 3 and 5, those are the exact opposites of the ones you found there. And that's the case whenever your leading coefficient is 1, or you just have x squared at the beginning like you do in number 1 and number 3. Number 5 is a little different. It's the same process, so let's move everything to one side. So we have 7x squared. We move the positive 20x, so it's minus 20x. And we have to add, right, we're going to subtract 20x, and we have to add 12. Move it all to the left side equals 0. Here we need 7. So we go to our box here. We have 7x squared and 12. And 7 times 12 is 84. So we need factors of 84 that add up to 20. So I can tell you this. I know they're both going to be negatives because we need negative 20. 84. Just kind of keep playing around with this thing. Eventually you'll come up with what you eventually end up with. Takes a little bit of work, but you end up with 14 and 6. So minus 14x minus 6x. So let's go ahead and pull out common factors. Here we can pull out a 7x. Here we can pull out a minus 6. Here we can pull out an x. And here we can pull out a minus 2. So my two factors here, 7x minus 6 and x minus 2, I'm going to set that equal to 0. So set each piece equal to 0. And x minus 2 equals 0. Actually, the one over here is pretty straightforward. It's just x equals 2. Over here, it's a quick two-step equation. Add 6 to both sides, so 7x equals 6. Divide both sides by 7, and it's a fraction, but not a big deal. X equals 6/7, or x equals 2. Now, another way you could approach these problems, you could use your Desmos to set these up. And again, to go find those solutions, put y equals x squared plus, or x squared minus 14x in one side. So if we were to go to Desmos and put that value in, or what I might suggest to you, type in, once you move everything to one side, I can kind of show you a trick. So x squared minus 14x plus 25. So x squared, excuse me, we go over to Desmos, y equals x squared, and then if you'll allow me to slide back over and take a look at it, it was x squared minus 14x plus 45, minus 14x plus 45, minus 14x plus 45. What you should realize, now you're just going to look for where that particular parabola touches the y-axis, which is 5 and 9. We go back to our work, and sure enough, we had 5 and 9 right there. So number 2, without doing really any work, if I go through and I put in the x squared minus 3x minus 10, so x squared minus 3x minus 10, you can see the two solutions there that you should come up with are negative 2 and 5. So I'll go ahead and jot those down for you it should be negative 2 and 5. So x equals one of those two things. You can see with number 4, it's already in the y equals, so x squared minus 3x minus 10, that's the same exact problem, so I'm not going to plug it in. Number 6, if I take a quick second, let me kind of separate it. Let me go ahead and move everything to one side. So 0 equals 3x squared plus 11x minus 20. So take a second here, 3x squared plus 11x minus 20. So 3x squared plus 11x minus 20. And here's a situation where one of the values is a decimal. And so that's going to be one, if you recognize conversion from decimals to fractions very quickly. If not, what you're going to have to do is you're going to have to go through and solve this thing. But you can convert your final answer to a decimal and see if it matches up. So negative 5 and 1.33, excuse me. So we should end up with x equals negative 5 and something that's equivalent to 1.3333. So again, you're going to want to go through and do the actual work to show your steps like I did for 1, 3, and 5. But Desmos is a great way to check your final answers.